We're going to go over a bunch of these today. So I would have been trying to work them to get my group points, but I digress. You do you, whatever. There is a math workshop test on Monday, and it's going in the 60% category. If you're not going to be here on Monday, if you want to come try to see me later today, you can. Otherwise, you'll have to wait till after the break. I'm not going to type in zeros until the end of the week where we return to school. It is a 100-point, 60% category grade. It is not a grade you should blow off. There are 20 questions on the math workshop test on Monday. 14 of the 20 are factoring. Again, 14 of the 20 are factoring, meaning over half of the problems on the math workshop test are factoring. Can you factor? So let's find out pretty quickly. If you don't tell me the answer fairly quickly, I'm going to tell you the answer and your group cannot get a point. Number 1. Okay, 3 and 4 get a, no. 4 and 5 get a point? No. Number 2. Okay, I think they're right, and so that would be 4 and 5 again. Let me check. So if you pull out a 2x out of the first, you'd be left with a 4a minus 3. If you pull out a negative 3 out of the second, you would be left with a 4a minus 3. They're not crazy. They did grouping. They already had it done like I asked. That's terrific. Number 3 is an easy factor where its leading coefficient's a 1. We need two things that multiply to 4 and add to 4. Table 2 gets the point, z plus 2 and z plus 2. 2 plus 2 is 4. 2 times 2 is 4. So a better way to write this would be z plus 2 squared. Number 4 is an even prettier problem because it's the difference of perfect squares. Yes, so we're going to write 2b plus 25 and 2b minus 25, so it gets another point. 2 squared is 4. 25 squared is 625. He is completely correct. Number 5 is our first doozy of a problem because the leading coefficient is not a 1. I'm going to use guess and check. If you want to use slide, divide, bottoms up, that is fine. Did you say it as well, Roberta? I didn't think so. 2, you get the point. They may or may not be correct, so let's check it out. Let's actually FOIL it out. So 5x squared minus 15x minus 3x plus 9. That does end up being 5x squared minus 18x plus 9. So they have guessed and checked correctly. The 5 and the x were kind of locked in. But the minus 3s, it didn't necessarily have to be minus 3s. It could have been a positive 9, a negative 1, a negative 9, a positive 1. There were some other options. But they guessed something, they checked it, it lucked out. If it didn't, they should guess something else. Okay, on to number 6. Let me zoom out so you can see both at the same time. Minus what? 7t. Oh, okay. Yeah, I got you. Ellie, you get the point. So it's taking a negative 7. W minus 7 is plus. Sorry, it's 17. Thank you, Ellie. And Tyler. Number 10. It's going to be a grouping because there are 4 terms. So we got the answer. Okay, let's see if he's right or not. So in that first group, I take out a 5x. I am left with a 2x, but not minus 3. 2x minus 7y. I think he's wrong. I think so. If I factor out a 5x, I'm left with a 2x minus 7y for the first group. From the second group, if I factor out a negative 3, I'm left with a 5x. Oh, I did it wrong. Oh, okay. Yay, I'm glad I made a mistake today. I thought you had it right. I was confused. I hate it when I'm confusing. Okay, so if I factor out a 2x, like he said, and squeeze that in among my mess, 2x, and I'm left with a 5x minus 7y, and that makes sense. I factor out a negative 3, I'm again left with a 5x minus 7y. So he's not crazy. It is 2x minus 3, 5x minus 7y. How dare I question him? Because I did, I'm going to give him 2 points. Number 8 is easy factor because it has a leading coefficient of 1. I need two things that add to negative 7, multiply 12. 4, I'm going to give you the point. Negative 3 minus 4 is negative 7. Negative 3 times negative 4 is positive 12. Number 9, 16 minus w to the 4th. Difference of perfect squares again. Going once. 2 and 4 get the point. 4 minus w squared is correct, and 4 plus w squared. Yes, the square root of 16 is 4, but we also have to do the same thing with the exponent, because 4 is also a perfect square in the exponent. Number 10 looks like a hard factor, and it actually is not, because there is a trick to it. Someone know the trick. There is a GCF to get another point. I don't care how many points you end up with today. That's terrific. So if you factor out a 3, you're left with a 5n squared minus 9n minus 2 equal to 0. So it should make the whole thing a little bit easier to deal with. Now, since I still have a leading coefficient of a 5, which is not a 1, I do have to use guess and check, or again, if you want to slide, divide, bottoms up, you can. So I know it's a 5n and an n. And then I'm thinking of things that multiply to negative 2. I can do positive 2, negative 1, negative 1, 2. There's not that many options. So what would you like to try? I'm feeling this, but I really don't remember. Again, I'm just guessing. Is it a positive 1 or is it a negative 1? Is it a positive 2 or is it a negative 2? Should they swap spots? I don't know. I'm going to FOIL it out and see if I guessed right. If not, I'm going to try again. So if I FOIL this out, I have 5n squared minus 10n plus n minus 2 minus plus n minus 2. And, oh, it all works out for me because that is 5n squared minus 9n minus 2, which is what I had. So this literally is the answer. However, they asked us to solve. I'm out of room, so I'm just going to say it out loud. But so the 3 goes away. We have 5n plus 1 equals 0, so n equals negative 1/5. We have n minus 2 equal to 0, so n equals 2. Well, they did by putting the equal 0. No other problem has had that equal 0. Okay, so there are 14 factoring problems. So I hope those were easy for you because there are 14 of those. It's over half the math workshop test. If not, I suggest you get out your old math workshops and maybe find my old YouTube videos and see if you can get a little better at it. Yeah, more practice. 3720, number 11's a doozy. I'm needing some perfect square that divides into 3720. I tried 64, I tried 16, I tried 36, I tried a lot of things. I've only come up with one number and it's a really small one. Is that a perfect square? It is 4 times something. It's 4 times 930. Oh yeah, it wasn't a good one. So I know the square root of 4 is 2, so I have 2 square roots of 930. I'll give a point to whoever can help me with the q and the r in their exponents. Q to the 3rd, r to the 12th. That is correct. You 2 can have another point. So 3 times 2 is 6, plus 1 is 7. It was q to the 7th. 12 times 2 is 24, so that's all worked out. Again, since it was an odd exponent, we have 1 left under the radical. R was an even exponent, so we didn't have any left under the radical. I don't know if I said this or not. I feel super repetitive today, and that is okay. There are, yes, 14 factoring. There are 4 radical problems. So 4 is something similar to this. 12 is a butte. because I like 324. Because it's a perfect square, which is 18. 2 and 3 get a point, so it's 18j to the 10th. Yes. And then last but not least, so 14 plus 4 is 18. There's still two types of problems we haven't discussed that are on the test. And those are both law of exponent problems. So can you handle your laws of exponents? Let's actually go in reverse. Let's start with number 16. When we're dividing, what are we supposed to do in the exponents? We are supposed to subtract, so the answer is 2 and 5 get a point. So when we divide, we subtract exponents. When we multiply, you add the exponents. So our answer is y to the 8th. Yes, I get y and y to the 8th, but combine those and give me 1 y. Y to the 9th. So it's really a 1 there. So 1 minus 6 plus 4, it ends up being y to the 9th. 4 can have the point. It's an understood 1. So 14 plus 1 is 15. 15 minus 6 is 9. So that was really what I was looking for to begin with. I was just humoring Jax with this middle bit. I went straight to y to the 9th in my brain. Okay, so we add exponents if we're multiplying. If we're dividing, we subtract exponents. We're going to skip 14 for a minute. What do we do if we're raising a power to an exponent? We do. 2 can have a point. You multiply the exponents. So literally, I'm going to do negative 2 to the third, b to the negative 2 to the third, c to the third to the third. So I get negative 8, b to the negative 6, c to the 9. But what can I can't leave it like this. What's my final answer? Why can't I leave it like this? What is the issue? Yes, it is exactly 2 and 3 and another point. It's that negative 6. So I cannot have a negative exponent. Instead, I punish it, and I do what with it? I do send it to the bottom of the fraction. 2 and 5 get a point. So it's negative 8, c to the 9th, b to the 6th. We're going to skip 14. I do not recall the problems on the math workshop test, but I promise you if they're a fraction like this, I'm going to rewrite them on the board, because I am not. I just cannot. But again, the whole point of that one would be if you have a negative exponent, you cannot leave it that way in your final answer. You've got to either move it, if it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. It has to move. Are there any major questions about math workshops? Okay, then get out your notes. Let's talk about what we did yesterday. Okay, we were talking about the quadratic formula. So we have a math workshop test on Monday, but we also have a quiz on Monday on completing the square in the quadratic formula. Completing the square, we've already gone over. I'm going to tell you specifically that there are 5 problems on the quiz on Monday. Only 5. It is going in the 30% category. There is an easy completing the square with a 1 leading coefficient. There is an easy one. But there is also one that I would call hard because the leading coefficient is not a 1, so you end up in fraction land to begin with. So it's one like we talked about yesterday with a hard, because it's a difficult leading coefficient, and one like we talked about the day before where it's just a 1 in the front and ends up being okay. Are there any questions about completing the square? Some people have shown me these 5 problems, some people have not. I'm not going to type in any zeros for it until probably Tuesday of next week. But you need to have tried these 5, especially since I've given you the answers and you have a quiz on Monday. If you never practice it, how are you suddenly going to pull it off on the quiz? I do not know. Speaking of not pulling things off, I understand the checkpoint is hard, and I understand you hadn't had that much time on it. I've only got, I think, 2 in the room that have passed so far, which is okay. I need that to be a lot higher of a number. When I stop rambling, that's what I would probably work on first, is can I finish the completing the square checkpoint? I'm probably going to post the key, or like the 3 answers, because there are 3 problems, the 3 answers over the weekend to try to help those who are still stuck. I know me, I'll probably type in zeros for that before Thanksgiving break. I know me. I'm not going to type in any zeros for the math workshop test or for the completing the square and quadratic formula quiz. But other stuff, I make no promises. Okay, yesterday we worked on page 24. We never did page 23. Page 23 is yours. It's also yours to do. There are 5 problems. And we're going to say it's due Monday, but honestly, the sooner you show me, the better. There's potential. So Monday the plan is math workshop test, quiz. Tuesday is more like a what are you missing / would you like to do a bonus that's a completing the square turkey. If you're not going to be here Monday or Tuesday and you want the turkey bonus, just let me know and I'll hand it to you today. So yes, I do want you to do the 5 problems on page 23. Those are yours to practice. Which means I don't have that many problems left to do. I've given most to you. I only have 2 left to do. Let's go to page 24. I hope last night I motivated you enough to at least memorize the formula. So again, 5-question quiz. 2 are completing the square, meaning the other 3 are quadratic formula. The hardest part of the quadratic formula is, do you know it? If you know it, life moves really easy after that. Really easy. I wrote in black on top of my pink formula. I highlighted that b squared minus 4ac. Why did I do that? I only get a point. That piece is the most important part of the formula. That part is the discriminant. It tells us everything about our graph as a reminder. So if we get a nice number under here, like a square root of 4 or a square root of 3, we're going to have 2 answers. So our graph is crossing the x-axis twice. But if we have a 0 under here, our graph is only crossing the x-axis once. And if we live in imaginary land, which is possible, then we're not going to cross that x-axis at all. So literally, just by calculating the discriminant, I already know a lot about my graph, and I've not even solved. I've not solved, I've not graphed. All I've done is calculate one tiny thing, and that one tiny thing told me a whole bunch of information. Okay, so we'll briefly review. So yesterday on number 6, we calculated the discriminant. We got a positive pretty number, which meant because it was positive and pretty, we had 2 real solutions, 2 real roots. So if Tylen were to type that function into her calculator and graph it, it better cross that x-axis twice. In fact, we calculated it, and it's supposed to cross at 1 and negative 1/5. So she could check with her calculator, make sure it really did cross at those 2 spots. Are there any questions about number 6? Number 7 is my favorite, probably your favorite too. We calculated the discriminant. Everything went away. We only had 0, which means that plus or minus thing is pointless. We only end up with 1 solution. But since it was 0, I knew it was only going to be 1 solution to begin with. For an extra point, not 1 solution, meaning our graph is crossing at only 1 point. What is that 1 point? If our graph is only crossing, because I put 1 real ring, it's only crossing at 1 point, what is that 1 point? It is the x-intercept, but what other part of the parabola would we call that? It's the vertex. That's what Paige said the other day. I'm surprised she didn't steal it now. You can have a name. So if it crosses only once, that 1 spot better be the vertex. Moving on to number 8. Yes, I know I always do well in math class when I play on my phone. Number 8, we need to find the discriminant first, which is b squared minus 4ac. Now, I think yesterday I said our first step is to calculate the discriminant, but that's not true, is it? What's our first step? Find the a, b, and c, and if it's not in standard form, we have to put it in standard form so we know the a, b, and c. Get a point. So right now I know the a is 7, the b is negative 11, and the c is 5. But if it was not in standard form, we might actually have to rework it to figure that out. Okay, so someone tell me the value of the discriminant. Plug in the A, B, and C and tell me what you get. So 121 minus 140. And you got negative 19. Okay, what does that, 4 and 5 can have a point. What does that imply about our answer? And so it has no real roots, but if we're being really fancy, you realize it means it has two imaginary ones. Yes, it has no real number roots, meaning it never crosses the for real x-axis, because the x-axis is dealing with real numbers. But technically, we do end up with x equals something, 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 I. So we do end up with an answer. It's not like we quit and throw our hands up and say, let's call it a day. Okay, and we seriously learned all that just from calculating the discriminant. Now we actually are going to calculate what those two imaginary roots are. So if you need to write the formula, you can. Honestly, if you know it, I just plug in the numbers. So for us, negative b is going to be negative 11. Plus or minus square root b squared minus 4ac over 2a is 2 times 7. I don't feel the need to recalculate that b squared minus 4ac. I already did that. I know that number is negative 19. I'm going to plug it in. Why I have to do math twice? That seems silly. So I get x equals 11 plus or minus something over 14. What is that something? Two and 5 get a point. Can I get the square root of 19i? Perfect. Literally, that's the answer I want. If you're trying to make life a little harder. If you want to break it into 11 plus square root of 19 over 14, 11 minus square root of 19i over 14, you can. But seriously, I'm good here. You're done. There's nothing else we can do there. Now, if this would end up being, let's say, the square root of 81, or like a perfect square, or something we could actually break down and go for it, keep trying, we can reduce it then. But 19, we can't do anything with that, so we're done. Are there any questions about number 8? We've just got number 9, which is good, because I've got a limited amount of space left on my paper. A limited amount of patience in my brain. Whew. What's wrong with number 9? How would you put it in standard form? Four and 5 get a point. Okay, so I want to know that discriminant. Which is the b squared minus 4ac. So for us, it's 3 squared minus 4 times 2 times negative 3. So 9 plus something. You know, point shots. So we found the value of the discriminant. It's 33. And let's just pause there for a moment and ask the kind of obvious question. We talked about in number 6, 2 real roots. We talked about in number 7, 1 real root. Talked about number 8, no real roots, 2 imaginary roots. Why am I bothering to do number 9? What's the deal with these roots? What are they? We got a 33, so what does that mean about our roots? Is the discriminant 0? Is the discriminant a negative? Is it a positive? What does that mean about it? Tell me about the roots. It's 2 real roots, 2 gets a point. If your number is not negative, it's not imaginary. If your number is not 0, it's not 1. Since our number is 33, there's 2 real roots. Why is number 9 different from number 6, discriminants-wise? That's exactly it, Gilberto, and you can have a point for that. 33 is not a perfect square. So the whole reason I'm working number 9 is to go over an example of what if the discriminant is a positive number, so we have 2 whole roots, but it's not a perfect square. What does that mean about our graph? Like, I get it's crossing twice, but more specifically, what about where it's crossing? What kind of numbers are those? They have to be decimals, because if it was a 6, if it was square root of 36, which is 6, that's how we ended up at like 1, 2, negative 1/5. For sure I know, because I've got an ugly discriminant, that these are ugly zeros. Just FYI. I don't know why I just thought second period would like that information. I'm sure you could have persevered and still gotten the right answer, really not overthought your life, but when I see an ugly discriminant, I know that means those are ugly zeros. They happen, but they're ugly. Okay, so then let's actually plug in so I can get on our answer. So, x equals negative b plus or minus square root b squared minus 4ac over 2a. So for us, negative b is negative 3 plus or minus square root over 2a. We've already calculated that discriminant. It was 33. Is there any way to break down 33? What times what is 33? Are either of those perfect squares? So, genuinely, I'm going to leave my answer. Like, my final answer is this. Negative 3 plus or minus the square root of 33 over 4. And that's what I would want to see on your paper. Now, Amory is smart. And she has her calculator. So, can she in her calculator express negative 3 plus second square root 33 divided by 4? If she did that, she would get 0.68. Here, I'll show you what I did. Let's say Amory wanted to know. She just wanted to know where that decimal was. So she did negative 3 plus the square root of 33 over 4. She got 0.686. So if we were to graph this function, one of my roots better be 0.686. So let's go y equals, it was 2x squared plus 3x minus 3. Press graph. Did I type that right? No, I did not. I knew it when I did it. Thank you, Jax. 2x squared plus 3x minus 3. Graph. So I'm assuming, because this one's a negative one, that this one to the right better be 0.686, or else we have really fudged up. So I'm going to put second calculate, 0, left bound, right bound, enter, 0.686. But you can see why I don't want the decimal answer, because again, Ryan might just be doing all the calculator tricks we've been learning to get the decimals. I don't want that. I want the radical. I want the radical. I want it with I. I want you to leave it messy. I mean, simplify it as far as you can, but don't give me no decimals. I don't want no decimals. Are there any questions about this? Okay, that's terrific. If I were you, you've got a ton of things to do. You've got completing the square homework, quadratic formula homework, and a checkpoint. It would be great if you could get all those things done. I understand why you won't, but wouldn't it be awesome if you did?